Hello and welcome to the Matthias iOS development show with me, Matthias, your iOS developer. And today we're going to talk about integers. Yes, that's right, integers, the numbers we use in Swift. And you might be thinking, hey Matthias, why are we talking about such a basic thing, right? You know, integers are like one of the first things you learn when you do computer science, when you do programming, along with strings and booleans. And turns out there's lots of cool things you can do with integers in Swift, which you might not know about, which I only learned fairly late here. And yeah, in true internet fashion, I've made a numbered list, so we can go through those and we can see what is that great about doing integers. And let's just start with number one, which is very large number formatting. So now if you have an integer here that is very large, say whatever this number here is, it might be kind of difficult to understand at a glance what it is. So what you can do actually in Swift is you can put in these markers here where you put in an underscore, and the entire thing will still run. Let's remove this one here. See, it still goes through, and now we have a visual shorthand for being like, all right, this is one. Oh, cool! This is this number. You can also in addition just put those things everywhere. I don't recommend you do that. Just put it at the 1000 markers, so we know that this is this number here, and it helps you read things. Cool. That was number one. Let's come to point number two, which is parsing strings. Now, as you all know, integer from string. Sometimes we get a number saved as a string, say an API returns it, or you want to read it out from somewhere. So what you can do is, there we go, you can parse a string like this by putting it inside this integer function and then running it, and this will read out the number value from the string here. Hey, check it out, this goes to 1, 2, 3. Now this does only work if it's a cleanly formatted integer to begin with. Say there's some spaces in here, this is going to fail. Or rather, if this parsing fails, we'll get a nil returned. This also only works if there's, this also doesn't work if it's like, if there's a special character in there, this will also return null. Nil if it's any kind of letters or a hex number, this does also not cleanly return a number. Also, very important, if the number is just too big to be contained in an integer. This will also fail and return a nil in this case. We're going to get to this point later. That's a bit of foreshadowing because we're going to talk about how big an integer can get in a few steps. Now let's get to point number three, which is float parsing. So let's say we have an integer and we want to parse this from a floating point number. So we're going to parse this from a double. And the way we do this is we also call the int function again. And then we put in our floating point number, and the way this parses the number is it's being rounded, but always in the direction of 0. So if we run this now, this is 21.5. This is going to round to the integer which is in the direction of 0. So basically in this situation we're rounding down. But what also can happen is if this number is negative, we still round towards 0, but in this case we will be rounding this up. So I'm actually going to make this a different one. We're going to round this from negative 28.5 to an int, and in this case it rounds upwards towards negative 28. Neat. There's also a thing you can do in float parsing is, let's call this the exact parsing, where if you type in exactly as a parameter name, this will only parse the number if it's already an exact integer to begin with. So this is 21.0. It's a clean number, there's like no floating point details afterwards, so we parse this to 21. But if this is, for example, if this one has some decimal value, 21.5, then this will not happen. This also returns a nil in this instance. And that way we can also check if a floating point number, a double or a float, is pretty much exactly an int or not. Cool, that's much for parsing. Now let's go to the next point, which is the 0 enum value, which is also pretty neat. So if you have a variable and you don't need to write 0, there's other ways of doing this. Of course, you can also create a variable like this. You can define it as an integer to begin with of type integer. This one here is automatically read out. And if you do it like this, if you write integer, right, we're declaring this. If we have a variable name integer colon, the data type, then you can also write this out as dot 0, which is a a variable we have access to here within the enum, here within the integer. And you don't really have to do this. I feel this makes the readability of the entire thing a bit more clean, because here you still kind of have, you know, the numeral 0, you gotta parse this in your head. Here you have the text 0, and we know this is an int. We can also make the case, this is actually much shorter, that is also fine. And what you can also use this for is to make comparisons. Now, I'm not sure about this. There isn't a good suggested best practice to dealing with this. And I asked around on Twitter, I asked some other developers what their consensus is. And what we figured out, if we want to have, for example, a comparison, if integer 2 equals 0, print hello. If we're doing a comparison in an if, in a ternary, for example, in any other condition, if it's just a single comparison where we compare it to 0, we can also compare it to .0, which kind of makes readability a bit better. But if there's a second condition attached to this, so if this is an if else, at this point it then doesn't make any sense anymore. At this point we might as well have this be just regular numeral 0 instead of our .0 variable. Cool, let's go to the next step, which is number 5. This should be an else if. Let's go to the next step, which is number 5, random numbers. So the int class in Swift comes built in with a random number generator. And the way we do this is we just call int and then random, and then we get a range. So if we say 1 smaller than 1 dot smaller than 100, this is the range from 1 to 100, non-inclusive. That means we're gonna get a random number output here between 1 and 100 non-inclusive. And there's no need to create a classic, unlike other languages where you need to import something or create a random number function. Number 6, the is multiple of function, which is really great. Now you've probably done a function at some point in your life where you do a modulo comparison, where it's, for example, you write 17 modulo 2. And as you know, the modulo comparison, you can also print this. As you know, the modulo operator divides this number here by this number and gives you the remainder of it. So 17 divided by 2 is, what is 17 divided by 2? 8 with a remainder of 1. And this is the number we get out of here. And the way to use this practically, in most cases, is you find out if a number is divisible by something else. Because if you do 17 modulo 2 and the remainder is not 0, then this number is not divisible by 2. Same with 3 or 4 or anything else, there's going to be some remainder in here. So if we do 17 modulo 4, it's also 1. Let's do 17 modulo 5. And this one has a remainder of 2. Now, Swift has a much easier function to deal with this. What we can do is we can do the is multiple of function. So for example, if we define an integer, that integer is 12, and then we're going to say integer is multiple of, let's say 5. And now what we basically get is we can see if 12 divides evenly by 5 or not. And this wonderful is multiple function here gives us a bool out yes or no. So 5 does not work, but 3 will work. Hence we get the true out of it, which is super neat, and you don't have to do these modulo operations anymore, which is cool. Now there's some edge cases to this entire thing. If, for example, the number you have is 0, then this is also going to be a multiple of 0. Because if you say 0 by something, it's always going to be 0. However, nothing is going to be a multiple of 0. So if this is not 0, if integer is something else than 0, and you're going to run the is multiple of 0, then you're always going to get a false. Because there's no number you can multiply this with to reach the result of this, which is pretty much the edge cases here. Alright, let's get to the next point, which is different types of integers. Now, and this point is so big and so complicated, this is not only point 7, but also point 7, 8, 9, and 10. And we're going to spend some time talking about this. So let's begin. Basically, when we write an integer, we usually always use this type here, int. But that's not really what we have available. So what we have fully available in Swift is these types, which is an int8, an int32, an int64, an unsigned int8, an unsigned int32, and an unsigned int64. Now, I'm not going to go into full detail how binary number representation works. We can talk for a full half hour about this. But what it means for us as a front-end developer is that, among other things, this int here, this is not the full type. Internally, this is either an int32 or an int64, depending on what numbers the system supports. So if this is an older computer, if this is an older phone, and they can only do 32-bit numbers on there, this is going to be an int32. And if they can only do 64-bit numbers on there, this is going to be, if they can already do 64-bit numbers, this is going to be an int64. And we can actually find out the different maximum minimum values of this by using the min and max function, which is our point number 8, minimum and maximum functions. So if we say int x.min, int8.max, and we run this, we can actually find out, oh, an integer 8 type number goes from -128 to +127. So if we have a number that's a let 8-bit integer, and we're going to put this to 127, this is going to, no, it has to be of type int8. This is going to work fine. But as you know, int8, the maximum number in here, can be only 127. So if we put this to 128, then this will fail. This will not work. This is not allowed. Same if we go to -128, this is allowed. Whereas going one below 129 is not allowed in here. And this will also produce a bug or a crash in an actual system. And then we also have the unsigned integers. Let's also call these one unsigned int8bit.min, and let's also call them unsigned int8bit.max. And let's see what comes out here. And oh, these are different. These go from 0 to 255. So what does all of this mean internally? Basically, as you know, as good computer programmers, as good computer scientists, in an 8-bit integer, we have 8 bits available to count our value. 1, 2, 3, 4, 1, 2, 3, 4. And now, using binary numbers, we can count this up. So this is 0, 1, 2, 3, 4, 5, 6, and so on. And the maximum number we can have with 8 bits is 1, 1, 1, 1, 1, 1, 1, 1. This is the full thing. And this is basically our spread from 0 to 255. Now, what this means in an unsigned integer is that this can only be positive. So we count from 0 to 255. What this means in a signed integer up here, which is a default value, this one goes, oh, it doesn't go from 0 to 255, it goes from negative det to positive det. Internally, that means the first sign, the first bit is the sign, is the plus or negative sign that deals how the rest is interpreted. Now, we're not going too much into binary numbers. There's lots of stuff to discuss in there. It's very fascinating, especially base number systems. Maybe I'll make a video on that sometimes. But basically what this means, if you have a regular int, it means it goes from negative something to positive something. If you have an unsigned int, it always goes from 0 to positive something. And this is just the 8-bit values. So if we replace this with the 32-bit values, set 32. Yeah. This is going to give us out much larger numbers because, soon as it, there we go, which is -2147 yada 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 to plus, and on the unsigned side, this is 0 to 429, etc. Now this is the maximum number this can be in here. And it's considerably bigger than our 8-bit integer number because this one has 32 bits. And this number here, maybe you've seen it occasionally, the 32-bit integer maximum number. Because, for example, there was a case many years ago where a World of Warcraft player reached the maximum number of gold possible that they could have. And it was exactly this number. Why was it this number? Because they had a 32-bit integer that was saving the amount of gold you would have, or copper in that case. and couldn't go higher, at least in that case. Maybe they've changed it in the meantime. And this leads us straight to point number 9, which is that we can actually have this wonderful function, which is called negating a number. So if we have a value and we say, and we call the negate function on it, what this basically means, it is that this number here, 21, will be flipped over to the negative side. So 21 becomes negative 21, but this can fail. How can this fail? Or x2 or y. So if, for example, this is an int 8 and it has the maximum negative value, or minimum value as we say, we cannot flip this one to positive, because if we say y.negate, this is going to flip to plus 128, but as we've just learned, int 8 cannot contain a plus 128, it only goes up to 127. So this function here will fail, and this will produce a critical error. Same thing if we have, for example, an unsigned integer. And now we want to negate this, because as you know, unsigned integers cannot be negative, they are always positive. And this will also fail. Hence, negate is super useful, but there are some weird side cases. And this brings us to the last point today, point number 10. How do we find out if a value type is signed? Which is, what we can do is we can use the isSigned function. So if we say int32, we just call the type directly, this is a static function, and we can ask isSigned. And this basically tells us, does this integer contain the capability to be negative or not? So int32 is true. If this is an unsigned integer, and we call isSigned, then we get basically false out of here telling us, okay, this does not. And that concludes today's presentation about 10 things you could do with Swift integers which you didn't even know about. And I hope you learned something from this, especially how integers and unsigned integers work. I find this super fascinating, especially in the sense of computer science and what we can do with bits and binary number counting. And I hope you picked this up. This might be useful to you eventually, and I'll see you next time.